Alrighty, so the problem was that Katie runs 57.9 meters eastward and then turns north and goes 1,875 kilometers, and it wants to know her resultant displacement and the total distance. So first things first, we want to get everything in the same units. So we want to convert the kilometers. Sorry, let's first do 57.9 meters east and 1,875 kilometers north. That's the first thing. So we want these in the same units. So we do 1,875 kilometers over 1. And then we multiply. We know there's 1 kilometer for every 1,000 meters. And so then the kilometers cancel out. And that gives us 875,000 meters. And so then we have them in the same units. So then what we want to do is we want to draw a triangle. So start at the origin, and we go east, 57.9 meters. And then this crazy woman runs, what was it, like almost 2 million meters up? I don't think she's running. She's like in an airplane. Okay, so that's 1,875,000 meters. So it wants to know her displacement, the resultant displacement. So that is, we know the displacement is how far away you are from the origin at the end. So that is that right there. So how do we find that? Well, awesome guy Pythagoras. That's a right angle, and due to wonderful Pythagoras, we know that a squared plus b squared equals c squared. So let's call that a, let's call that b, let's call this c. So 57.9 squared plus 1,875,000 squared will equal c squared, but to get rid of the squared, we would square root that, and so we square root this side all the way. And so that is what c is equal to. So you just plug that in the calculator, get your magical answer. And don't forget sig figs and stuff. Those are important. So it is a vector, which means it has magnitude, and direction, which means it's doing something and it's doing it in a particular way. So being 100 meters positive is not the same as negative 100 meters, even though that is technically the same distance. It's 100 meters, but they're in different directions. So what we want to do is we want to describe in what direction this crazy woman's running. Oh yeah, and we went right because east. Yeah, north, east, south, west. So, I mean, we go east and we go north. So, then what we would do is to describe the direction that she's going. So the actual triangle probably looks a lot more like that. Just a huge giant line and then a tiny little blip to the right. And like connect these two without totally blowing it like I am. No. Yeah, it's hard to hold a phone and draw at the same time. So it's a really, 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 really skinny triangle. We know that's a right angle, and that is the angle we want to find. So let's go look at a triangle that's easier to work with. We want to find that angle, right? Angle theta, let's call it. So, wonderful trigonometry. We have the side adjacent to angle theta, and the side opposite angle theta, and this is the hypotenuse. So we would use tangent to find the angle theta. So we know that tangent of theta is equal to, what is it, opposite over adjacent. And we don't know theta, so we actually want to solve for that. So arctangent, or inverse tangent, of 1875000 over 57.9 equals theta. Plug that in a calculator and it'll give you an answer, and I'm doing this in my head, but it's going to be 89.99 something something degrees. Let's say, like, yeah, I'm not even gonna try XX. It's gonna give you 2 more digits probably, but it's gonna be extremely close to 90. And you want to make sure your calculator is in degrees, not radians, because that would be bad if it was in radians. And so that's the angle that it's at. And since this is, you can just describe the angle, but you also probably want to describe the direction in terms of northeast, southwest. So you would probably just describe it as north, considering she goes almost 2 million meters north and barely even, she goes like basically 50, well, she goes 57.9 meters to the east, which is nothing compared to almost 2 million. So I would just describe her as going north, basically. And then it wants to know the distance. So distance is the total amount that you traveled over the whole thing. So your displacement, so like let's say you start here. You can go like this, blah 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 blah, and end up here. Or you can go like this, loop-de-loop, and end up here. The displacement is the exact same, because your distance from the origin is the same for both of them. But the distance that you traveled is not. This line is not the same length as this line. This one, the jaggedy one. But they both end up, they're both the same distance from the origin. So how you find the distance of this is you add up all the line segments. So that would be 57.9 meters. That is not a good 5. 57.9 meters plus 1875000 meters. And that will give you your total distance. And that's a scalar quantity, which means it does not have direction. It just has magnitude. So it's doing something, but it doesn't tell you in what direction it's doing it. And then, yeah, I think that's it. Don't forget sig figs. Sig figs are important. So yeah, hope that helps. Yay!